Hi guys, um, very good evening. How was the sessions? I think, look pretty tired. It's already 4, just 1 hour to go. Um, I looked at the agenda and it was pretty amazing. Looking at all the data engineers, data scientists, data engineering leaders in the same place, talking about a lot of data stuff. Amazing, amazing. Um, yeah, without a delay, let's kick start. My name is Rakesh. I'm part of ClickHouse solution engineering team. I lead solution engineering in India for ClickHouse. Been in the data and data space for more than 13 years now. Worked with most of the databases and data spaces in the past. Uh, we'll talk about ClickHouse in detail today. A lot of you guys came to our booth and was asking about what is ClickHouse, et cetera, right? So the takeaway from this session would be to understand what is ClickHouse, where does it fit, and what are the architectural patterns where you can use it, et cetera, right? So I would keep the agenda in that way. And if you have any questions, I would park that Q&A during, you can come down to our booth and we are happy to assist. We have our team there. We'll take it forward from there, right? With this, a little bit history about ClickHouse before I jump in and talk about what is ClickHouse and what does it do, where does it fit, etc. I think most of your company has already started using ClickHouse. I saw a lot of your company organizations, etc. So we know that your companies are already using ClickHouse, whether it would be open source or ClickHouse Cloud or any other offerings. We'll talk about that as well. Just talking about the history, ClickHouse is there from quite a long time, I would say. Started with 2008, 2009 with our founder, Alexei. Started this database product. He realized that the data, the click stream, the warehouse was not there back in the 2008-9 time frames. It was all people were using Oracle, SQL Server, and other items. So the word ClickHouse comes from the keyword clickstream data warehouse, right? That is when Alexei decided to build, we need to have a data warehouse at that point in time, and the journey started from there. So 2012, we went into production, and 2016, we licenses in Apache, and 2021 is when we incorporated as a company, ClickHouse Inc. In this last 4 years, the engineering effort and the integrations and the engine itself has enormously grown, and I'll talk about some of the features and functionality about that as well, right? So if you see ClickHouse now, there are very less number of databases now, especially handling analytical space. I would say it's the #1 analytical database on DB engines, and over 39,000 GitHub stars, which is amazing. We are almost touching to Apache Spark. Very soon we are going to cross that, and over 200K of community users. Just a quick background about ClickHouse and the history. Talking about what is ClickHouse, right? So think of ClickHouse as a pure play analytical database. It's a SQL distributed database, comes with the purpose-built operation for handling a huge amount of data with blazing fast analytical capability with scale. That is important. A lot of databases can do analytics, they can run aggregations, but when it comes to volume of data, handling terabytes and petabytes of data, that is when ClickHouse comes into picture and serves for the purpose. So there are 3-4 main components I would consider when you're talking about ClickHouse, right? So it's a SQL database, as I said, distributed SQL, processing the data very fast. We store the data in a very highly compressed and encoded format, very efficient algorithms to reduce your overall TCO of the storage, right? And easily scalable to any size. It's massively auto-scalable. You can scale up and down very easily, seamlessly, scalable, right? So this overall together makes some important features of ClickHouse. And also, just to summarize now, right? So ClickHouse being an analytical database, now it has evolved, as I said, in last 4 years. It has evolved in such a way that it's no more just an analytical relational SQL database. It has gone beyond, above and beyond. So we have become now a unified data platform to analyze the data and also to contextualize the data. When I say unified data platform, you can stream the data, you can load the data, structured, semi-structured, unstructured data, horizontally scalable, distributed SQL, real-time processing. Very less databases does real-time analytics, and we'll talk about some of the architectural patterns as well. When you say analyze, so we are, again, ClickHouse is a columnar database, very well efficiently built to handle a very large amount of aggregations. And if you have a requirement of ingesting millions and billions of records, then we have something called ClickPipes, which makes your applications more data intensive and much more real time, right? And built for low latency and high concurrency. And now we are all talking about AI and generative AI, agentic workflows, etc. So a lot of engineering efforts and investment has been gone into contextualization of the data, meaning you can have agentic workflows with ClickHouse. You can store the vectors within ClickHouse database used for semantic search, hybrid search, and also you can use it as an offline feature store, right? So as I said, very easily used for processing SQL, JSON, which is semi-structured, time series, and other formats of the data. So it's more of a multi-model where you can store all type of data in one single platform, which is amazing. So building on ClickHouse, so we are seeing two patterns here, right? So what is ClickHouse used for? Where does it fit, right? So it is very good for two cases. One, if you are using ClickHouse as a primary data store, meaning you have a new projects, and let's say if you have a sensor data, telco data, or any data which needs to be analyzed and used primarily for that, then you can use ClickHouse for that. Absolutely fit for that. And a lot of customers are also using ClickHouse as an analytics layer, right? So that is where the USP comes into picture. So if you have any relational databases, everybody uses relational databases, transactional databases, Postgres, MySQL, you name it, right? Oracle. But at scale, you will not be able to do analytics. So you will have to move the data to some data warehouse or other analytical platform to get the real-time insights. You can do that with a lot of other products, but getting a real-time insights is a challenge. That is where ClickHouse comes and solves. Data lakes, easy integration with data lakes, Iceberg, S3, Delta, and open table formats, very easily doable, right? So we have a lot of table engines which can directly get connected to other databases and pull the data into the system and start querying that. So two types of medians, I would say, where ClickHouse fits very well. Coming to use cases, so a lot of people ask this question, right? So what are the different use cases, where I can leverage ClickHouse into? There are 4 important verticals we categorize it. One is primarily the main is real-time analytics, where you power your application. It could be your generative AI applications, it could be your native applications, used for very large amount of data, aggregating it. As soon as, when we say real-time analytics, the term, right? So the meaning is, as soon as the data comes from any data source, it has to be available in a real time. As soon as it gets committed, it has to be available. A lot of databases suffers that because even though it is distributed, there is a rebalancing, reshuffling, a lot of things has to happen before the commit will take place, right? So we have a little bit uniquely architected in that way so that you get a better in time to insight when you start querying the data. So business intelligence again is extended unit of real-time analytics, I would say. Lot of your applications get connected to Power BI, Tableau, and other business intelligence tools. So when you say your dashboard is slow, actually your dashboard is not slow, your database is slow. That means your queries underneath is not performing well, right? So that is where ClickHouse comes into picture, where you can do a lot of modifications for a different query patterns and get the faster insights on your data warehouse or business intelligence tools to serve for both internal and external customers. Logs, events, and traces, one of the important vertical in ClickHouse for observability. So you can monitor, stream the metrics, traces, etc., detect the anomalies, fraud, any issues out there, and easily monitor it and take actions out of it, right? So how fast you take actions of it is very important. Your applications or your organization cannot wait when you detect an anomaly and to take an action on top of it, right? So while the data is flowing in, you will have to identify if there is an anomalies or anything happening in your system and immediately take actions. That is where ClickHouse is also, a lot of our customers are using it. I'll also show some of our customer case studies as well. Machine learning and generative AI, again, it's a lot of investment is going on, as I said. We are now getting vector search into GA very soon, probably in a couple of months, where you can store, where you can use any LLMs, chunk your data, put it in a vectors, and then start doing a hybrid search, right? Contextualize, use vector indexes. It could be cosine or Euclidean distance, nearest neighbor match, and all of those things. So very efficient. And DeepSeek, by the way, everybody knows DeepSeek, so uses ClickHouse as a vector store behind the scenes, and they have announced this in public as well. Some of the logos you can see, just some of the big logos who use us with respect to that particular verticals of ClickHouse. Good. ClickHouse cloud architecture. So before getting into that, there are three main offerings with ClickHouse. ClickHouse is open source SQL distributed database. You all know that now. ClickHouse cloud architecture is slightly different, and this we started with 2021, as I said in my initial slide. We have divided, ClickHouse has been now divided to cater the data into separation of compute and storage, right? So when you start ingesting the data, all your data will be backed by object storage. Virtually, you really don't have to shard your data. It's a single unlimited sharded system, right? So it's a limitless database for you. And with that, you have another layer which is compute. It's all Kubernetes-based pods. You have multiple nodes around it. When you start querying the data, based on your query patterns, the data will be pre-warmed and stored in this multi-layer cache. So this becomes your faster access of the data, right? So there are multiple caching layer here. I'm talking about file system caches, uses fast SSDs here. There are a lot of other caches which you can use it to pre-warm the data and use it. And you can always use your object store data for your historical needs and etc. The beauty is now when you start writing the queries, right? So the application writes the query, it gets into load balancer, it goes to different nodes and fetch the data if the data is already available in your cache. If the data is not available in your cache, it goes into object store, prefetches the data into cache and keeps that into your as a hot layer and serve the data immediately into the clients. And you have an admin console, which typically takes care of monitoring, backups, billings, and other things, right? So this is a very high-level ClickHouse cloud architecture, and it's slightly different from what open source architecture is. And there are a lot of things inside compute and object store, how we store the data, how we compress the data, how we encode the data, and how we decompress the data. That is where all the uniqueness comes into picture when compared to any other. You might have seen a lot of other databases saying compute, separation of compute and storage, etc., right? So, but how efficiently you store the data and how efficiently you retrieve the data is very, very important. With ClickHouse, you get almost 10x compression. That means if you have 1 terabyte of data, you probably just end up storing 100 GB of data in your object store. Yep, this is the main concept of ClickHouse cloud architecture, shared merge tree design, meaning the compute nodes and the object storage has a connection with ClickHouse Keeper, where it will keep all the metadata information in ClickHouse Keeper. It knows which node has which data, so that it goes and particularly picks up that particular amount of data and gives it back into the system. Virtually, object store has unlimited storage, gives you very high insert throughput, and the merges and mutations will be very, very efficient in shared merge tree. And this is not there in the open source, and this is the main differentiation actually. So the replicated merge tree, if you know about ClickHouse in open source, is replaced with ClickHouse cloud architecture by shared merge tree design. Yep, traditional architecture, data architecture, you might have all seen this, used this, and done some work with this. A lot of complexity here, a lot of data sources. It could be data coming from other databases, applications, servers and devices, etc. There could be 2 methods only you could stream, right? One could be either streaming and other could be batching. Streaming could be Kafka, batching could be anything like, use Talent, Informatica, etc., and put that data into Lakehouse. And Lakehouse also comes into a lot of tools and techniques. Probably you might use Hadoop or any object store like S3, blob storage, etc., and do some transformation. So a lot of things happening in the Lakehouse. That is where a lot of time has been consumed. Moving of the data is happening. So the time to insight is more when using this traditional style of data architecture. And finally, you have to move to any data warehouse or analytical system to visualize that data, access that data patterns. With ClickHouse, what we do is we simplify this architecture, reduces the system bloat, and increases the resource efficiency, right? Now, if you see ClickHouse being in the middle, the streaming layer always will be there and batching layer will always be there. We need some tooling to stream the data into system. That will be done either through Kafka or any other mechanism. But in the real-time data warehouse where ClickHouse sits, so you can do all of these 4 use cases in single platform. There's no data movement from, let's say, S3 to a transformation layer and then to databases like ClickHouse, Snowflake, and or BigQuery, Redshift, etc. And we also have a great integrations with data lakes. You can directly get connected to Iceberg, Delta Lakes, read the Parquet files directly from S3. A lot of integrations are directly available. There are a lot of table engines where you can directly fetch the data as well. And you can also get connected to OLTP systems like Mongo, Postgres, etc., and make this more resource efficiency, avoid the complexity of the data structure. So when I say real-time analytics, I think I've said this multiple times, right? So what do we mean by real-time analytics in ClickHouse is using ClickPipes, right? So this is another feature which ClickHouse Cloud brings onto the table, where it acts as a man in the middle between your data sources and database. ClickHouse seamlessly uses massively parallel processing technology and put the data into the ClickHouse. And there are a lot of integration engines available. Good to read about that. later time. There's a projections where you can store the data in the hidden table, where if your, let's say if your where conditions is not there in your primary index, and if you want to query that, it's a common problem across data industry, right? So it has to go to a different projections and fetch the data. So very efficiently can be done with ClickHouse. Materialized view, we have two types of materialized view. Incremental materialized view, which does pre-aggregation and start filling up the data, and also refreshable materialized view, where it gets refreshed for every 5 seconds, 10 seconds, 15 seconds, and configurable as well. Yep, the landscape has evolved from last 30 years, as I was talking about, from traditional data warehouse like Oracle, Vertica or Hadoop, Teradata, etc., to a traditional cloud data warehouse from last 10 years. If you see Redshift, BigQuery, Snowflake kind of a databases, and now where we are is real-time data warehouse. That is where ClickHouse is coming into picture. There is also a real-time data warehouse and offline data warehouse as well. So we stand at real-time data warehouse, but we also can do offline data warehouse like Databricks, Iceberg, and other platform does as well. So it's basically we are becoming more simplified, cost-effective, getting unlimited scale with low latency and high concurrency kind of needs in this data-intensive application world. Combining data lakes with analytical database, right? So if you have a data source, you can write either directly to a real-time data warehouse analytical system like ClickHouse, and also write to a slower inserts to maybe Delta Lake, Icebergs, and etc. Right? So you have the system in two storages. You can connect both of them and use data lake for a historical purpose, and use real-time system for your most frequently used data, which requires a faster performance needs. There's also another pattern where just the raw data goes with the slow insert goes and sits in data lake, but this will powered by ClickHouse, gets connected to data lake as a query engine and starts pulling the data and giving the results to you, right? It can do both times, and again depends on use case to use case. So good to have the both writes and reads from real-time warehouse and also offline data warehouse as well. What makes ClickHouse unique, right? So first of all, it's a columnar base. It's not row based. We don't. It's not a very good fit for us if you want to do a single seek operation, single updates. Traditional databases or traditional transactional databases is really good for that, but there's always need for transactional database. So we're not replacing transactional database. We are more of a columnar database where you go pick the subset of the columns, go deeper, pruning, and pick only the relevant granules where the rows are required, and give it back to the client. Multiple layer of indexes. We have different types of indexes, right? So ideally, the data stored in ClickHouse is called as granules. These are the set of rows, the chunk of rows that grouped into a logical unit called as granules. And we have something called sparse primary index where it tracks these granules. Now, when you query this data, if the primary key index, sparse primary key index matches, it goes and fetches only that particular granule and skips all of the other granules. And this has been efficiently designed using vectorized query engine within ClickHouse, and that is one of the USP where you get lot and blazing fast performance, milliseconds on billions of records and trillions of records, maybe terabytes to petabytes of data. Efficient merging, right? So whenever there is a data warehouse distributed system, merging is very, very important. When you insert any data in ClickHouse, you create something called as parts, right? That is where the granules is stored. And when you create a lot of inserts, it creates a lot of parts. But efficient merging is very important. Behind the scenes, we track all of these parts, keep merging these smaller parts into bigger parts, and then push that down to object storage, right? So when you have a larger part, it's very easy to access the primary sparse key index to access that particular granules and give the details out of it. So again, there are different table engines. What happens during a merge? There's a table engine called merge tree, which combines the parts without deduplication. You insert all the rows and keep all the rows. Very good use case for append only kind of a use case. There are a lot of sub-family of this merge tree. Good candidate for reading. Replacing merge tree, if you have a requirement of, okay, I have a data coming in, I also have a duplicates, I want to remove that duplicates, then use replacing merge tree to eliminate those duplicates. Very ideal for absurd kind of a scenarios if you have that in your system. Aggregating merge tree, again combines the parts by aggregating the rows. If you want to pre-aggregate the data as the data flowing into the system, it can be done using aggregating merge tree. So we have a lot of merge tree engine tables where it is built for different purposes, right? So very unique actually, and there are a lot of table engines which can directly connect to different databases and read the data as well, and write the data back as well. So these couple of things makes really unique with ClickHouse. Some of the architectural efficiencies has been incorporated from last 1 year, which includes compute separation, which is also called as workload isolation. If you have a very high write throughput and also read heavy kind of a workloads, so we can separate your services to write the data into one service and read the data into from the other services, right? Basically, you are doing workload isolation with shared object store. So both of the services, the important point here is it shares the same data, right? So the data is being written into service 1, but you can read the data in service 2, which is cool. ClickPipes, as I said, is an integration engine where you can bring the data from various different data sources. These are some of the logos you can see where you can easily bring the data sources into the system. Very efficient, very blazing fast. Ingest, you can use MPP technology and put the data into the system. Lot of integrations, third-party integrations. When you take any database, it has to have a good ecosystem around it. And we have more than 250 plus integrations out there, right? So you name ETL tools or a BI tools or a streaming tools or a batching tools. We are all have a native connectors with ClickHouse so that you can consume that all ecosystems from whatever cloud provider you are using it. ClickHouse for real-time analytics, as I said, right? So use ClickPipes. That's where the real-time analytics comes into picture. Use the dictionaries, projections, and makes the system blazing fast. So one of the use case for real-time analytics, customer left. We ingest almost tens of millions of rows, and also execute millions of read queries on ClickHouse daily. So we are talking about 25 terabytes a day of data. They are ingesting it and reading it into the system in a real time. And when I say real time, I'm talking about milliseconds here. The second use case, which is data warehouse or BI, as I said, so use again ClickPipes, very good candidate. Use table engines and put the data into the system, and UI layer you can use, as I said. So we have native connectors for all the BI tools out there in the market, and make your dashboards as a fast boards, right? So we call it as fast board and ClickHouse when some tools, when Power BI or Tableau get connected to ClickHouse. JustPay is again one of the use case with BI or data warehouse. It's one of the leading fintech company in India. The SDKs of JustPay, the software has been installed in more than 200 million devices, doing more than 5 million transactions a day, right? And doing aggregations on top of it, and they have to run 200 to 500 reports on a daily basis, and they want this in the real time to make the decisions real quick, and they are leveraging ClickHouse for this. Observability, very great use case. If you have a hotel collector, if you are anybody from observability, then use Kafka, Streamit, and use Grafana for monitoring. We have a great integration with Grafana and HyperDX, alerting UI and reports as well. Cloudflare uses us for observability, and if you see, Cloudflare uses 2 petabytes of data for ingesting 2 petabytes of data into the system, and they uses logs, metrics, and traces into the system and identify if there is any malicious traffic in the system and take immediate actions, right? So these are some of the 4 important use cases I would put into different verticals and some of the examples of the customers. Yeah, and last, not but the least, ML and generative AI, right? So we have integrations with almost all LLMs. You take it OpenAI, Anthropic, and we have a ClickHouse MCP server now where you can get connected to a Claude kind of a tool and start connecting to ClickHouse service, and you don't have to really write a SQL query. It does it for you automatically. You don't have to create a report as well. It does it for you. So it's going really well. Anthropic and Claude with MCP server, I think it's definitely must try. I can show some demo as well if you come towards our booth. Tools and visualization and the models and AI services. You train your data, store all your data in the vector format, and start contextualizing that. Cognitive uses for a feature store for training ML models, really fast and cost efficient. A lot of their data science team uses it. Again, it uses 2 petabytes of workload in ClickHouse Cloud as well. So one of the use case. That's it. It's just the main idea or purpose for you all to understand what is ClickHouse is, where does it fit, and what are the architectural efficiency. Happy to answer any questions in our booth. You can join our community channels and etc. Thank you so much, guys. Thanks for having me.